This is an instructional video for Mechanics of Material 1, MET 241, Tensile Test Lab. The following equipment will be used for tensile testing of an aluminum and steel test specimen. We have two specimens here, steel and aluminum. A gauge marker to mark a 2-inch gauge section of both specimens that will be used to determine the total elongation of the test specimens. A caliper which will measure the diameter of the specimens and the elongation that we get from our 2-inch gauge section. And an extensometer which measures strain, which will tell us the modulus of our aluminum specimen. To perform the test, we will be using a Tinius Olsen test frame and data acquisition system to record the displacement and diameter of the specimen. 5 measurements shall be taken at various places on the gauge section, and an average specimen diameter will be calculated. After measuring the diameter of the specimen, it is placed in this fixture evenly and hit with a hammer to show your 2-inch gauge section. And into the test frame now. On the software page, we're going to want to make sure on the file load test setting that metals tensile is selected. After measuring the specimen's diameter and marking the gauge section of the specimen, we are now ready to load the specimen into the test frame. On the test software, under File Load Test Settings, make sure the metals tensile test setting is selected and that the power switch on the side of the system is in the on position. The specimen will be threaded into the upper adapter, and then the bottom piece comes up and spins on. You can then jog the crosshead up to take the slack out of the system and thread it fully onto the specimen. Once the specimen is threaded, we will take it out of mechanical control or manual control, and we can come over and take this crank and lower, take the rest of the slack out of the system until we see a slight preload on the specimen of around roughly 5 pounds. In order to mount the extensometer, it should be placed around the center of the bar away from the radius. It should be then this lever on the side should be turned down, and then it should be clipped into place on the specimen and zeroed out. We are now ready to start the test.
Go.
Alright, under the Live menu tab on the data acquisition, we can now hit the Test Now button. And our test should be starting now.
Now.
10,
Now.
13. Now we want to remove the extensometer after it reaches its maximum range to avoid any damage. That's done by pushing the release clip and removing the device. The aluminum specimen broke at 15,300 pounds load. So from here we can remove the specimen from the fixturing. Once you remove the specimen from the fixture, put the two halves together and you measure the distance between your initial 2-inch gauge mark. Control print screen, open up the paint program and hit Control V to paste the screen as a paint file. This will show your test and your ultimate load. This file can then be saved and printed out along with your lab report. Well, for testing the steel sample, the same steps will be followed, except there is no need to mount the extensometer.